Now this is the lesson number 11 in differentiation, which is studying the variations of functions. شوف احنا we are used to functions to be written as like this. For example, f of x equals 3x plus 2 مثلا over x minus 5 مثلا. But in this lesson we will see sometimes that they will give me functions but in a different way. How exactly? They will give you functions like this. الحين هذه this table now is a function. This is the description of a function. Okay? So and we want to get some information from this description. Sometimes they will give you the function like this as a graph. Okay?
هذا يدخل.
أيوة. Well, sometimes they will give you direct questions like these direct questions. طبعا in the past year هم صاروا يدوا direct questions like these questions. But before كان في questions like this, tables, graphs. We will see how do we deal with these now. شوف.
يعني في احتمال إنه يدخل.
في احتمال yes. Now let's see. Look at this. The first thing we need to understand is what are the components of this table. يعني ايش المكونات في التيبل هذا. شوف. This table is composed of x. The first row is x. The second row is f derivative of x. The third row is f double derivative of x. The last row is f of x, which is y. Same thing here. Look, the table has 4 rows: x, f derivative of x, f double derivative of x, and y. Okay? أول شيء I'm gonna teach you كيف تتعامل with this one اللي هو f derivative of x. Okay? Now look, f derivative of x, let's write it here. F derivative of x can have one of 3 possible values in the table. They can write that f derivative of x is positive, or they can write it's negative, or they can give you that f derivative of x is 0. Look, f derivative is the gradient. When the gradient is positive, معناها إنه the function is going upwards. إيش يعني going upwards؟ معناها إنه f of x is increasing. طيب. If the gradient is negative, معناها the function is going downwards. And if it's going downwards, معناها إنه f of x is decreasing. طيب. When the first derivative is equal to 0, this is what we saw in the previous lesson. لما تكون ال first derivative equal to 0 بيظهر معنا على طول نعرف إنه معنا critical point. What are the critical points? Critical points هم يكونوا يا إما maximum or yes maximum or minimum or saddle inflection point, or minimum or saddle inflection point, saddle inflection. Okay, look. Now, when is it maximum? It's maximum when there's an arrow before the function that goes up, and then the other arrow goes down. Maximum معناها we climbed to the function and then we went down from it. Minimum معناها we went down to the function to the point and then we climbed after that. So now we climb to the point and then we go down. And now we decrease to the point and then we increase. Saddle inflection point is when you have both directions before the point and after the point. They're both what? Either increasing or they're both decreasing. So one more time. First derivative has 3 cases. What are the 3 cases? It can be positive, A positive means that the function is increasing, okay? Or it can be negative.
decreasing.
Or negative means that the function is decreasing.
Or 0.
Or it can be 0. And if it is 0,
Critical.
it means that we have a critical point. Critical points, one of 3 points. What are the 3 points?
The maximum, minimum, or saddle.
Minimum or maximum or saddle inflection point. Okay. With this information, let's see now how do we deal with these two tables. Look at this table first. Look. Now I want you to pay attention to the first derivative here. Okay? What do you see in the first derivative? The first thing we see is that we have a positive sign. إيش يعني هذا البوزيتيف sign؟ معناها إنه the function here is increasing. فاجي لتحت وأرسم سهم upwards. This means that this function is increasing. من فين لفين? From here up to the 0. We stop at the 0. So this place, the function is increasing. Okay? Here,
The critical.
we have a critical point. At 0, we have a critical point. بعدين, after that, past that,
The decreasing.
because it's negative, the function is decreasing. So we draw an arrow down and we shade this with red. هذا decreasing. طبعا, by the way, he gives you the signs. He gives you the table like this. He doesn't give you the arrows. These arrows, you need to draw them yourself. بعدين هنا, we saw this is negative. I'm going to draw an arrow here. This arrow goes down, okay? And I'm going to shade this with red. So here the function is decreasing, right? طيب, وبعدين I got 0 again.
The critical point.
So I understand now that this is a critical point. So here we have a critical point. And past this critical point, what do I have?
Increasing.
I have the function here is increasing. Okay, so at the critical points, احنا معنا 2 critical points, right? At these critical points, highlight the whole column like this. الcolumn كله
critical point كنا بدنا نقول إنه two derivatives.
The critical point first derivative.
First derivative equal to 0.
First derivative equal to 0. Yes. So also here, this is a critical point where the first derivative is equal to 0. طيب, الكريتيكال point هذه ممكن تكون يا maximum يا minimum يا inflection point, صح؟ What do you see here? What's this one? خلاص, هذه critical point again وهذه another critical point. شوف. At the first critical point, there is an arrow that goes up before the point, and then there is an arrow that goes down. Okay? So if it goes up and then goes down, means that this one is a maximum. Okay? طبعا, this is the x coordinate of the maximum, x, and this one is the y coordinate. And this point is -1, -2, x, y. Here, the function goes down
minimum.
and then it goes up, so this place is a minimum. The x coordinate is 1, while y coordinate is 2. تمام? So let's check now the questions. مثلا, this question here, he says that the function f of x decreases. أروح أنا لعند الجراف أشوف where does it decrease. طيب, decrease معناها goes down, صح? Where does it go down? It goes down from here, do you see? Up to here. صح؟ يعني it goes down from -1 up to 0.
From 0 to 1.
وكذلك from 0 to 1. Also, يعني union نقول from 0 to 1. Okay, look at this. Why is 1 blacked out? ليش ال1 كذا فيه خط أسود? This blackout at 1, this indicates that this one here at 0, this is a gap in the function. شفت لما كنا نطلع في vertical asymptotes الgaps ناخذ the denominator make it equal to 0. So if we take the denominator make it equal to 0 and we solve for x هيطلع لنا هذا الجاب. So the gap is here. So where does it decrease? شوفوا, -1 here, -1 will be included like this, closed bracket, means the decrease starts at -1. Up to where? 0. Because 0 is a gap, I'm gonna open this bracket. So write it outside. Then we open brackets of gaps. بعدين union with 0,
0.
we open the bracket until what? Until 1. And we close the bracket because 1 is not a gap. So this is the decrease interval نسميه احنا. طيب. Where is it in the choices? We will not find this. مش موجودة في الchoices. ليش؟ كتبها بشكل ثاني. What did he write? He wrote from minus 1 until 1. From minus 1 until 1. هذا الخط معناها except
0.
the 0. ليش except الزيرو؟ لأن الزيرو هي gap. Exactly. So it's from minus 1 until 1 except 0. So this is the correct choice. This is when the function decreases. Okay.
If it is increase.
Let's see. The second question says here, the function f of x increase in the interval. هنرجع لهم. So, where does the function increase? It starts increasing here up to here. That's an increase interval. From negative infinity to negative 1. And then another time from 1 to positive infinity. So, this is the choice. From negative infinity to negative 1, negative infinity to negative 1, and union from 1. أيوة, لأنه there are two intervals. From 1 to positive infinity. Now, infinity is always open bracket. Always. Like gaps. Infinity and gaps. They're always open brackets. Minus 1 is a point inside, so I'm going to close it. طبعا, they can open this as well, no problem. For points, it's okay to open it or close it. It's okay. But for infinity and gaps, you must open it. And you don't have a choice. هنا, I'm going to close this. And at infinity, I'm going to open it. So it's going to be this choice exactly. So, choice 2. طيب. What else I can solve from this table now? شوف, he's asking me about the local maximum value. طيب, فين the maximum value? Let's come back to the table. We said that this one here, this one is a maximum, صح?
Yeah.
Yeah. This one is the maximum. طيب. كم الx تبع الماكسيمم وكم الy؟
Negative 1
الx negative 1 والy negative 2. So what is he asking about? He's asking about x. So how much is the value of x? It is negative 1. طيب. The function has a local minimum value. Okay, let's come back to the table. Where is the minimum value? It's here, صح? What does he want? He's quiet. He did not say at x. يعني ايش يشتي? يشتي y, exactly. So because he did not mention that he wants x, so here they must, or they want what? They want y. Will y value come here? 2. Okay, good. طيب, هذا أول table. Let's check the other table. What does this table do? Let's go directly into the first derivative. So the first derivative here, positive معناها إنه هذا المكان ماله increasing. So I'm gonna draw an arrow here that goes up. بعدين هنا also increasing. So I'm going to draw another arrow, and that arrow goes up. And then the third one also increasing. So this function increases all the time. So I'm going to draw a third arrow here that goes up.
يعني دائما maximum.
يعني شوف, ما فيش فيها maximum or minimum لأنه ما فيش my zeros. So I don't have critical points. There is no maximum, there is no minimum, but it goes up all the time. يعني هي this function, by the way, it looks something like this.
طيب, ليش maximum minimum؟
ما فيش فيها. شوف, it increases and also increases. لكن ما فيش معي increase then decrease. When do I have maximum and minimum? If it's increasing then decreasing, or decreasing then increasing. But as long as it's increasing all the time, it means that this one has no critical points. So he says the function increases in the interval from minus infinity to minus 1,
to positive,
or from minus infinity to minus 1 and from 1 to infinity, or from minus 1 to 1, or on its domain. On its domain معناها all the time.
All the time.
Yes. And in my question, it increases all the time, so this is the correct choice. So this is how we deal with the first derivative in the table.
If you sit from negative to negative or positive negative.
لا except the gaps. He has to say except minus
So
1.
the gaps.
أيوة.
خط.
لأنه الجابس هذولا are not going to be included in any solution. They're not in the increase or decrease intervals. Okay? طيب. This is how we deal with the first derivative in the table. Let's check something else. Let's come back to here, to the tree. The first derivative we said it's either positive or negative. Positive معناها increasing, negative معناها decreasing. It can be zero. If you get zero, then you have a critical point. That critical point can be a maximum or a minimum or a saddle inflection point. طيب الآن the second row in the table talks about the second derivative. والsecond derivative دائما هتوصف لك حاجة اسمها concavity.
اللي هي up or down.
أيوة upwards downwards. Look.
لا دخل الليفت ماكسيمم.
The same here. So it can be either positive or negative or zero. If it's positive معناها the function is happy. So f of x is concaves down. Concaves up. Concaves up. Concaves up معناها open towards upwards. وهنا this is sad. So f of x concaves downwards.
Zero slant.
لا at zero when the second derivative is zero. When the second derivative is zero معناها معانا inflection point. كده كنا نتكلم في درس critical points.
في حاجة اسمها slant.
slant asymptote. That's for asymptotes. asymptotes and I mean long division or take the x. Yes. So if it's positive again, the function مالها concaves upwards. And if it's negative, then it concaves down. And if it's zero, we have an inflection point. خلاص, this is the only thing that we need to know for the second derivative. Let's go back to the table now. Let's check the second derivative. Let's see this table. Okay. Here. The second derivative, look at the second derivative now. It's positive at the beginning. Positive معناها concaves up. فأنا أرسم كده happy. وهذا المكان I'm gonna shade this place from minus infinity until minus 1. هذا المكان concaves up. The negative معناها concaves down. Sad. So I'm gonna shade this place as this place concaves down. بعدين معنا إيش؟ معنا positive again يعني happy. So this place concaves up. Okay. And eventually I have this place is negative. So it concaves down. Good. And there is a zero here in the middle. This zero here
inflection point
means that we have an inflection point. So this place must be an inflection point. كم الX تبع inflection point? الX is zero.
والY zero.
والY كمان zero. And I'm gonna write here that this point is an inflection point. So let's check the question about that. Here, he says, the function concaves upwards. In which interval? So concaves upwards. نشوف هنا في التable. Concaves upwards from negative infinity. صح? From negative infinity until negative 1. And negative 1 is a gap.
0 to 1.
And from 0 to 1.
1 is a gap.
And 1 is a gap. So it's this one.
Bracket.
From negative infinity to minus 1, and minus 1 is a gap, so it's open bracket. Minus infinity is always open.
Negative 1 is a gap.
Yes, negative 1 is a gap. From 0 to 1, and 1 is also a gap. So it's this choice.
مش شرط يكون الجاب zero.
No, the gap can be at any number. Now, the second one concaves downwards. Where does it concave downwards?
Negative 1.
From negative 1, which is a gap, until 0. And from 1, which is a gap, until positive infinity. So from negative 1, which is a gap, until 0, and from 1 to positive infinity, that's choice number 12. بعدين هنا كمان في معنى the function has an inflection point. Where is the inflection point? 0 and 0. يشتري الx والy. So 0 and 0. Okay, good. طيب
بس مش خلنا always negative ولا infinity or positive والزيرو يكون هنا مفتوح.
الزيرو لا. We said what must be open always is infinity and gaps.
and gaps.
Gaps not zero يعني. طيب this one, let's check this one. هذه the second derivative has two concavities. Concaves down في البداية.
up.
Concaves down in all of this interval from minus infinity all the way until zero. And then it concaves upwards. Concaves upwards in this interval from zero until positive infinity. Now, what does this mean? It means we don't have a zero. يعني معناها we don't have an inflection point. We just have concavity intervals. هذه concave upwards. Where does it concave upwards? واضح إنها من الزيرو, which is a gap, صح? Until positive infinity. So from zero until positive infinity, I need this one. Concaves upwards. Concaves downwards.
From negative infinity.
From negative infinity until zero. From negative infinity until zero. So that's concave downwards. Okay. خلاص كذا نكون كملنا. How do we translate the first derivative and how do we translate the second derivative? Yes. طيب. في أشياء كمان ثانية موجودة معنا في التابل. هنا in the previous class we talked about asymptotes. And we said that there are three kinds of asymptotes. الasymptotes كانوا إما vertical asymptotes
horizontal
اللي يكون x equals a number or horizontal asymptotes
y equal
اللي هو y equals a number or slant asymptote
x y
اللي هي y equals mx plus c. Okay, so we had three different types of asymptotes. These tables show us two of these three. In the tables, we can always figure out what are the vertical asymptotes, and we can also figure out what are the horizontal asymptotes. كيف؟ شوف. الvertical asymptotes احنا في الحصة الماضية كنا نقول انها inside the gaps. في البداية we look for the denominator, we make it equal to zero, so we look at the gaps. Same thing here. In this table, I can see the gaps. How many gaps do I have?
Two.
I have two gaps. طيب كنا نسوي check بعدين. كان الcheck إنه limit when x approaches a يطلع لنا كم؟ infinity. f of x اللي هو ال y gives us infinity. هل في check هنا؟ Yes. Look at this. Look at this gap. At 1, I do have a gap. And around this gap, what do I see?
infinity.
That's the check. So, as long as this check is correct, it means that we have a vertical asymptote here, which is x is equal to negative 1. That's the equation of the vertical asymptote. X is equal to a. Okay? I have another vertical asymptote also at 1. So, the gap is good and the check is good. So this means that we have a vertical asymptote at x is equal to 1. So we have two vertical asymptotes, yes. And these two vertical asymptotes are x is equal to plus minus 1. There is no question about vertical asymptotes among the questions. لكن I can write this as a note here. Note إنه في معنى vertical asymptotes. Vertical asymptotes.
هلا على عود درس الأول إنه متكرر مرتين.
No. At x is equal to plus minus 1. طيب شوف. In the second graph, do I have a vertical asymptote?
لا.
إلا. But only one.
Zero.
Yes. I only have one vertical asymptote at x is equal to 0 and the check is good. So we have a vertical asymptote at x is equal to 0. So in the table, in the questions, they asked me here about the vertical asymptote. So they're saying that we have a vertical asymptote at which one? And we say here that we have one at x is equal to 0. Okay? So that's my vertical asymptote. طيب. What about the horizontal asymptote? The horizontal asymptote يكون y is equal to L. Where do you find this? You find it when the limit of x goes to plus or minus infinity of f of x. كنا ناخد leading term على leading term. شوف. Where do you find this exactly? You will find it at the bottom corners of the table. Bottom corners of the table, but they must be equal to each other.
لا مثلا
Two bottom corners. شوف again. So vertical asymptotes, how do we, where are they? They're located in the table inside the gaps. They are written as x is equal to a, and we check the value of y around the gap because it has to be what? Plus or minus infinity. That's the check. In horizontal asymptotes, they are located in the table in the two bottom corners if the two bottom corners are equal to the value of L.
it must be equal.
أيوة. Look at this table. The two bottom corners are indeed equal to each other. They're equal to how much?
0.
To 0. طبعا it doesn't have to be 0, it can be any number. It can be 2, 3, 4. أهم شيء يكونوا equal to each other. If they are equal to each other and they are y, صح?
Yeah.
That's your horizontal asymptote. Your horizontal asymptote will be y equals 0. So, when they ask me about the horizontal asymptote, the horizontal asymptote would be y is equal to 0. طبعا it doesn't have to be 0 all the time. It has to be this number all the time, whatever this number was. The number at the bottom corners.
If it is not the same.
If it's not the same معناها إنه there is no horizontal asymptote. فمن يظهر لي؟
الإسلام.
يظهر لي السلانت asymptote. So والسلانت asymptote هذولا we cannot get the equation. We cannot get the equation. Cannot get the equation from the table. يعني we can tell that there is a slant asymptote, but what is the equation? We don't know. يعني مثلا look at this next table. The two values at the bottom corners, what are they? One of them is minus infinity and the other one is positive infinity. معناها إنه here we don't have a horizontal asymptote, we have a slant asymptote. But what is the equation of the slant asymptote? We just don't know. Okay? طيب. Something else in the table that we can figure out متعلق بالاسيمتوتس تكلمنا also عليه الحصة الماضية كان infinite branches. احنا in the previous class we said that each one asymptote always gives us two infinite branches. يعني we count them, every asymptote gives us two infinite branches. مثلا this table now, this table has three asymptotes. What are the three asymptotes? واحد اللي هو vertical, اثنين also vertical, and the third one is the horizontal اللي هو y is equal to 0. If you have three asymptotes, يعني how many infinite branches do you have? 6. Exactly. You can also figure out the infinite branches in a different way. How is that? Look. You can say that the infinite branches are these places. شوف هذا أول واحد. Why? Any column that has infinity somewhere in the column is counted as one infinite branch.
One infinite.
So this is one infinite branch. If there is infinity in the column.
Okay.
So this is now here, this is the second infinite branch. This is the third infinite branch. Do you see infinity at the bottom?
Yeah.
This is the fourth infinite branch because we have infinity also at the bottom. This is the fifth infinite branch. We also have infinity at the bottom. And this is the sixth infinite branch because we have infinity on top. So how many infinite branches we have? We have 1, 2, 3, 4, 5, 6. يعني this is the number of infinite branches.
أنا عد الانفينيتيز.
مش تعد الانفينيتيز، تعد الكولمز اللي فيه infinities. Let me show you this one like why. شوف. And how many infinities do we have? Up and down. In this column شوف. In this column we have two infinities, one up and one down, صح? But we don't count it as two infinities. We want it as one infinite branch. Because every column is counted as one. So this is one infinite branch. This is the second infinite branch. This is the third infinite branch. And here we have the fourth infinite branch. So how many infinite branches do we have? We have 4 infinite branches. So here we have 4 infinite branches. I think it did not ask about the infinite branches, so let's just write it as a note. So here note f of x has 4 infinite branches. Okay. One more thing we can find from the table. We can find the values of limits from the table. How do we find the limit from the table? Look, the limit is quite clear. It's self-explanatory. شوف هو ايش يشتي منك؟ يشتي منك y f of x صح؟ He wants y. And what did he give you? He gave you x. How much is x?
Plus minus 1.
Negative 1.
Huh?
X is negative 1.
Negative 1.
He wants y. So what do? You go to the table, add the x, you go to negative 1. Once you reach negative 1, you go down and you check how much is y. How much is y?
Negative 2.
Negative 2. So you just choose negative 2. That's it. That's the limit. So the limit is the value of y at the point specified. So they give you x is equal to negative 1. They want y. So this is what you do. You just go and find y. طيب مثلا هنا, look at this one. Here he wants the limit when x goes to infinity and he wants y from you.
Go to infinity.
خلاص, we will go in the table to infinity. So this is the table here. We will go infinity. So we will go all the way until here, up to infinity, right? And then at infinity, we'll go down and check how much is y.
0.
So how much is y? 0. So we come here and we check. We choose 0. Right. Look at this one. Limit x approaches negative 1 and there is a positive at the power. I'll come back to that. شوف الpositive هذه at the power. This is how we read it. We say from the right. ولو كانت negative at the power, we say from the left. What do we mean from the right? شوف هذه الإشارة we usually use it when we have gaps. x goes to minus 1. احنا حنروح لعند الماينس 1. حنلاحظ ان الماينس 1 هذه now we went to minus 1. حنلاحظ ان الماينس 1 هذه عبارة عن gap. We don't have a value of y. فايش عمل؟ Because he specified the positive direction, I'm going to look at the right. And I'm going to write the number that I see there. So what do I see there? Negative infinity. So that's the value of the limit. So x approaches with negative 1 from the right. The answer is what is it? Negative infinity. Yes.
معناها عبارة حركة زائدة.
أيوة الحركة الزائدة اللي هي go to the left, go to the right. And we do this always at gaps. Whenever there are gaps, because we don't have y. So because we don't have a y at the gap, they will tell me either go right or go left. طيب. Look at this one. Limit x approaches 1 of f of x. Now let's see this one. X approaches 1 of f of x. مشكلة هذه. It's a gap as well. But he did not tell me to look at the left or the right. So I'm gonna look at both of them. Now, if I look at both of them, do I see the same answer or do I see different answers? If I see different answers, I'm going to write that this limit that he wants from me does not exist. Why does not exist? Because the left and right not equal. If they're equal, we write the answer. We write the answer, whatever it was. يعني لو هو positive infinity, we write positive infinity. لو هي both negative infinity, negative infinity. لو هو both number, we write the number. So the left and right are not equal. So this is why that limit does not exist. خلاص باقي حاجة واحدة أخيرة في التيبل هذا. What is it? It's what we call the domain. والdomain هذا is something easy. Domain هكذا تعريفه. الdomain هو possible values of x. يعني لا يعني look at x and look at what are the possible values. Where does it start from?
Negative infinity.
And where does it end?
Positive infinity.
So the possible values of x are all the real numbers. From negative infinity to positive infinity except the gaps. What are the gaps? Negative 1 and 1. So this is this is the domain. So look at this. Yes, all the real numbers except the gaps which are negative 1 and 1. So this is the choice. Of course we cannot choose this one. ليش؟ هذا is an interval والinterval معناها from minus 1 until 1 يعني as if he's telling me that all of this is gaps, all of these are gaps, and that's not true. The gaps are only at minus 1 to 1, not from minus 1 to 1. Of course, each bracket has a different meaning. This is a set bracket معناها minus 1 or 1, okay? طيب, the second one, شوف, what's the domain here? The domain is all the real numbers, صح? شوف, where did the domain start? From minus infinity, yes, until positive infinity, except the gap which is at 0, so r except 0. That's the domain. خلاص, these are all the possible questions that they might ask you with tables. طيب, let's move on to the second type. شوف, هذا هرجع للجراف الأخير. The second type of questions is what they have started to ask recently. For after 2 exams, they give you questions like this, direct questions. And في هذا direct questions, احنا في معنا one main idea that we have to understand here. حاجة اسمها studying sign. هنشوف ايش معنى studying sign now. Look, he says the function f of x equals 2x squared minus 4x concaves downwards on its domain. True ولا false? شوف, concave downwards في التابل هذا حقي. Concave down, when does it happen? When the second derivative مالها is negative. So this is what I want to check. He is telling me هل second derivative is negative? That's what I'm wondering. On its domain معناها all the time. صح؟ كلمة on its domain شفناها من قبل فوق.
معناها all the time. fx to derivative 1
يعني the second derivative هتكون negative all the time. Let's check that. Let's find the second derivative. So the first derivative
تكون 4x minus 4.
هتكون 4x minus 4.
هذا 4.
And the second derivative would be 4. طيب, 4 هذا is a number. What's the sign of this number?
Positive.
طالما هذا positive معناها it concaves upwards all the time, not downwards. He said downwards معناها this one is what? False. Okay. Let's check another question. He says f of x equals 1 over x squared plus 1 is increasing on its domain. لحظة, بس increasing, what does increasing mean? Increasing means the first derivative must be positive. The first derivative, because let's come back to the table, to the tray here. Increasing معناها إنه first derivative is positive. Okay. So this is what I want to check. I want to check if the first derivative is positive or not. On its domain معناها all the time. So is the first derivative positive all the time or not? Let's check that. But before I check that, I want to ask you a question. If I give you 2x, what is the sign of 2x?
Positive.
If I give you negative 4x, what is the sign?
Negative.
خطأ طبعا. لا هذه positive ولا هذه negative. We actually don't know what the sign is. Why don't we know? Because there is x. X might be itself something negative in this example. If x is negative and we multiply it by 2, the final answer will be negative, not positive as you said. And here x itself might be negative. And if it is negative times negative 4, it will be something positive, not like what we expected. So when we have x, we cannot tell if the sign is positive or negative. You need to know this. Here in this question, did we have x?
Yes. No.
We had only 4, so we could tell. We said directly that the sign is positive. But if we had x, we couldn't tell that if this sign is positive or negative. So let's see. We'll see what to do. Now let's take the derivative. شوف, we have x in the denominator, so the first step would change the sign. We give this a power. What is the power? 1. We multiply the power up, so 1 times 1 is 1. We add 1 to the power down, so x squared plus 1 squared. Then we multiply by the derivative of what is under the power without the power. What's the derivative of x
2x.
squared? 2x. So we can write this 2x on top, jumble 1. So it becomes 2x over x squared plus 1 all squared in negative. إيش الإشارة هنا؟
نيجاتيف.
We don't know.
لا هنا صح.
Because there is x.
طيب ايش الجواب؟
فايش نعمل؟ نعمل حاجة اسمها studying sign. What is studying sign? Studying sign is always two steps. The first step, take the expression. شوف, put the expression that you have. الexpression هذا سواء كان the first derivative or second derivative. Put it equal to 0 and solve for x. هذه أول خطوة. بعدين the second step, study signs on a number line. هوريك الآن كيف. شوف, يعني أول خطوة I'll put the expression equal to 0. يعني I'll take this. الحين نشوف نكتب هنا إنه what do we want to do? We want to study sign. So we take the expression which is minus, let's take the minus on top, minus 2x over x squared plus 1 all squared, and I'll make it equal to 0. Cross multiply. So negative 2x is equal to 0. Divide by negative 2. So x is equal to 0. طيب, we found the value for x, صح? What is that value? 0. Now what do? We study the signs on a number line. How do we do that? نرسم number line. Okay. On the number line, this number line starts at negative infinity and goes all the way up to positive infinity. صح ولا لا؟ طيب, نطرح الزيرو اللي احنا طلعناها, whatever the number was, doesn't have to be 0, whatever the number was. نطرح this number in the middle, 0. Now what do we do next? We choose something before 0 and something after 0.
1.
مثلا negative 1.
Negative 1.
What do we do with these values? We substitute them in the expression that we're studying the sign for. هنا بدل x. And we don't care about the value, we care about the sign. If you put negative 1 مكان x, negative 2 times negative 1 would be positive. في denominator, because everything is squared, it will also be positive. Negative 1 squared, negative بيطير. So it will be also positive. So positive over positive means that this one is positive. هذا first derivative طبعا. So here it increases. From where to where? From negative infinity until 0. الآن, let's choose something else. We chose 1. Let's put 1 here. So if you put 1, negative 2 times 1 is negative 2. So it's negative on top, and in the denominator, it's positive. So negative over positive is negative. This means that here the function decreases. He says increasing on its domain, يعني all the time. Does it increase all the time? لا, it increases from minus infinity to 0 only. So this is why this is false. Okay? طيب, next one. شوف. The curve of the function f of x equals x cubed plus 1 concaves upwards on the interval from 0 to infinity. Let's check that. شوف.
إذا كانت فرضاً مش كيوب سكوير.
لو كانت فين كيوبد؟ هناك.
هنا.
لو كانت squared. concave upwards. أيوة. We said yes. بنشوف الإشارة طبعا. So this one here concaves upwards. معناها we want to check which derivative.
Which derivative?
Concaves upwards.
Critical.
First يعني إيش؟ First. Yeah, second. First نعمل increasing, decreasing. Concaves upwards and second derivative must be what? Must be positive. So we want to check if the second derivative of x is more than 0 or positive. Okay? Positive. So let's do that. Let's find the first derivative. So the first derivative would be equal to 3x squared plus 0. The second derivative would be equal to 6x. There is an x. معناها we don't know what the sign is. So we need to study sign. How do we study this sign? We put
equal to 0.
6x equal to 0. Divide by, so x is equal to 0. So this is the value of x. Now we draw a number line. So this is a number line. Okay? Starts at negative infinity, goes to positive infinity.
جواب
I'm gonna put 0 here.
كيف دام مدري
Let's see. Let's choose something before and something after. Something before 0, like -1 again.
-1.
And here like 1. طبعا هذول ال values we can eventually erase them because these are not the answers. The answer is from -1 infinity to 0. -1. Let's put -1 now in the second derivative. بيكون -6. So the second derivative would have a negative sign here. معناها sad. And if you put 1, 6 times 1 is 6. That's a positive value. معناها happy. And we want concaves upwards. So concaves upwards from 0 until positive infinity. He said from 0 until positive infinity. معناها he is correct.
نفس السؤال الأول.
It's true. أيوة هنا قال all the time. هنا لا. طيب. This question is asking about the concept itself. He says the function f of x increases on the interval from a to b if the derivative is more than 0. هل هذا الكلام سليم؟ Does it increase if the derivative is more than 0? The first derivative. متى increases? Let's check again. متى increasing?
Which is positive.
لما يكون the first derivative positive. و more than 0 إيش معناها positive ولا لا؟
أيه.
يعني هذا true ولا false?
True.
True. Okay. I'll come back to this question in a bit. This is exactly the same question. If the first derivative is more than 0,
Increasing. More
then,
than 0?
then it's increasing. Yes. طيب, this one. The function f of x, which is equal to 30x minus 3x squared, increases. معناها, what do we want to check again?
Increase.
We want to check if the first derivative is more than 0, positive. So let's come here and find the first derivative. So what's the first derivative? 30x, what's the derivative of that? 30. Minus 6x. We have an x, يعني we need to do what? We need to study sign. So,
Equal to 0.
how do we study the sign? We take 30 minus 6x and we make it equal to 0. Take negative 6x here. So 30 equals 6x. لا, divide by 6, divide by 6. So x is equal to 5. طيب.
صح, حتى لو كان ما وديناش بنكنسل
Negative with negative. And then we draw the number line. So let's draw a number line from negative infinity until positive infinity. And here we have 5. Choose something before 5 and something after 5. So something before 5, choose 0. 0 is always a good choice if it's available. Well, something after 5, let's choose 10, for example. So this is where we want to study the sign in the first derivative. So if you put 0, 30 minus 0 is 30. Positive, meaning it's increasing. 10, 30 minus 60 is negative. So it's decreasing. Okay? So it increases in the interval from minus infinity all the way up to where? Up to 5. So from minus infinity to 5. This one, the function f of x equals 3x squared minus 6x decreases. يعني first derivative must be what? First derivative must be less than 0. Negative, yes. So how do we check that? We go and find the first derivative first. So the first derivative would be equal to 6x minus 6. There is x, يعني we have to study the sign. So we study sign.
x equal to 1.
صح؟ هنعرف إنه x is equal to 1 because 6x minus 6 is equal to 0. 6x is equal to 6 means that x is equal to 1. Now we draw the number line. So this is a number line. Yes, if we choose something before 1, we will get something negative. And if we choose something more than 1, 2 for example.
0 هنختار.
هنا اختار 0. هنا اختار 2. طيب 0 in this place will become negative 6. So negative 6 means decreasing. And if you choose 2, 6 times 2 is 12. 12 minus 6 is 6. Positive, so increasing.
Infinity to 1.
So from minus infinity to 1 is the place where it decreases. So it's this choice. طيب وهذا the function f of x, which is equal to cosine x, which is in the domain from 0 to 2 pi. هنشوف ايش معناه. The curve of the function concaves upwards. Concaves upwards معناها انه second derivative مالها positive. Second
More than
derivative
zero.
تكون more than 0. So let's find the second derivative. The first derivative is negative sine x. The second derivative
Negative.
is negative cosine x. There is x, so we need to study the sign. So put negative cosine x,
zero.
yes. Study sign.
Cosine 0.
So negative cosine x is equal to 0. And multiply by negative both sides. So cosine x is equal to 0. Now how do we remove the cosine? By using cosine inverse in both sides.
استخدم القلم الكوسين خارج.
No, cosine inverse 0. What is cosine inverse 0? يعني what is the angle that gives you 0 in the cosine? Cosine what gives you 0?
ايش كنا نقول في
90 لا 0 لا cosine 0
لا بس انا جالس احسبها بدماغي.
أيوة. 90 what else كمان
270
270 which is 3 pi over 2. So how many answers did you find? طبعا these answers are between 0 and 2 pi. So I'm gonna draw now a line, a number line, but this number line is not from minus infinity to plus infinity.
في باباي.
From 0 to 2 pi.
ليش؟
لأنه حدد لي x from 0 to 2 pi.
كاتبها.
أيوه. والآن أطرح هنا 90 pi over 2 and 3 pi over 2. And now let's study the sign. Okay. First of all, let's choose something less than 90. Any angle less than 90, 45 for example, if you put it here, cosine 45 is root 2 over 2. Positive times negative is negative. So this one is be negative. Negative معناها this is the second derivative. صح? So it means that this place is sad. طيب, let's choose something between 90 and 270, which is 180 for example, pi. Cosine pi is negative 1. With the negative,
positive.
becomes positive. Positive معناها this place is happy, so concaves upwards. Choose something more than 270 and less than 360. If you choose 360 itself عادي. If you choose 360 itself, لأنه هذا closed interval. So it will be negative cosine 360 يعني negative 1. So negative. So this is sad. So where does it concave upwards?
هو upwards.
أيوة. Concaves upwards between 90 and 270. So this is the place where it concaves upwards. So it's the fourth choice. خلاص. This is how they're asking questions in the past 2 years. يعني you need a lot of answers. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. ما ينفعش لأنه هيكون ال infinite number of places. أيوة. He has to, in this question he had to give you this one. طيب. الآن نشوف the third type of questions, which is when they give you a graph. And this is an easy type. شوف. أول حاجة لكن before you start, I want you to know how to deal with the graph. شوف. أولاً الجراف هو the curve in red. Do you see this one? This curve and this curve. This is the graph. This is the curve. أما هذا blue line, this is a slant asymptote. وفي هنا كمان by the way, في هنا مثلا هذا البلاك لاين هذا الآن هو الفيرتيكال اسيمتوت. في تو اسيمتوتس في الرسمة هذه. في واحد فيرتيكال وفي واحد سلانت. وكيف أنا عارف إنه في اسيمتوتس؟ الاسيمتوتس هم البوردر لاينز اوف ذا فانكشن، يعني they enclose the function. الفانكشن ترسم داخل البوردر لاينز. فأنا معي واحد هنا واحد هنا، يعني حدود الفانكشن. So الاسيمتوتس بشكل عام. So we have two asymptotes. هذا الكيرف مقطوع هنا، يعني مشى على الحد، يعني ماشي على حد. الحد هذا هو الفيرتيكال asymptote. Same thing here. This is a vertical asymptote on top. And here we have a slant asymptote. This one is a slant asymptote. Okay? طيب.
لأنه مشى يعني.
لأنه برضه نفس الشيء، بس هذا مايل. أيوه. We always look at curves from the left to the right. Okay? دائما. Like you read words, like you read sentences, from the left to the right. شوف. This place here, هذا المكان, this place is an infinite branch.
Infinite. يروح إلى ما لا نهاية.
أيوة branch.
كنا نقول two infinite أصلاً.
هنا في مثلاً أيوة two infinite branches. واحد هنا وواحد هناك. So this is an infinite branch. What does the function do here? It increases.
Increases.
So it increases all the way up to this place صح؟ So
كاتب إنه negative 1.
because we stopped at this place شوف اطلع كذا specify this place on the x-axis. This is important. يعني هنا اكتب على x-axis إنه هذا المكان كم هو بالضبط. This is negative 1. What is the function doing here? It's increasing. شوف إيش بعمل الآن. بروح on the x-axis بعمل shade لهذا المكان بالأصفر. Why? Because the function is increasing.
خذ الإكس.
أيوة الإكس دائما الشيد على الإكس axis. So we shade on the x axis. This is the place where the function is increasing. بعدين what happened to the function next?
Decreases.
It's decreasing.
Negative 2.
So it's decreasing in this place صح? So I'm gonna take this marker and I'm gonna shade this place. It means that this function is decreasing in this interval. لكن انتبه معي على حاجة. At zero itself there is no function. لأنه شوف أنا لما أرسم الفانكشن حرسم كذا حواصل بعدين حرجع كذا بعدين I'm gonna get close to zero and get close to zero and getting close to zero but I'm not gonna touch the place where zero is. So zero itself is called a gap.
Zero gap.
ليش gap؟ لأن إحنا I'm gonna jump over the zero to come to this place. صح؟ I'm gonna draw this and then somewhere I'm gonna jump and come back here. So as long as I'm gonna jump, this jump over is a jumping over the gap. So here, this must be what? This must be a gap here. خليني أرسمها أولا. So this here is a gap. وهذه as we said before هذه معناها this place is where the function decreases. طيب. هنا this arrow indicates that we have a second infinite branch. صح؟ هذا as we said this place is a gap. طيب الآن what happens after that? What happens after the gap? We see the function again. The function appears after the gap. It disappears before the gap and then it appears again after the gap. So in the gap it's not there. So the function here what is it doing? It's decreasing. صح؟ Decreasing up to this place. So I'm gonna specify this place on the x-axis. So this place is 1. I'm gonna shade this place with the highlighter. This place is in red. So this place is decreasing. Then what is going on with the function? It is now increasing until we reach an infinite branch. So we have here now 2 infinite branches. These two are 2 infinite branches. So, infinite branches. Now let's see. Look. So I'm gonna draw here. I'm gonna highlight this with the yellow because this place is a place where the function increases. And here I know that this goes to positive infinity. I know that this starts from negative infinity. And again, I'm looking at the function from the left to the right. Now let's say it. What do they want from me? They want the domain.
Domain.
We said the domain is everything in the x-axis except the gaps.
يعني بتكون هذه.
R except 0. بالضبط. R except 0. So everything except the gaps. طيب. They want where the function concaves upwards.
Upwards.
Concaves upwards and is smiley. Happy. The function is happy in all of this interval. صح?
From negative
Where does
1.
where's the
From negative 1 to كاتب.
where's
لا 1.
the furthest point in the left and what is the furthest point in the right? The furthest point in the left مش عند ال1.
0.
بعد الزيرو تماما. So it starts at 0.
أنا كنت بقول بس قلت 0 gap ما هو.
بس gap يعني we open the bracket. يعني بعد الزيرو. And where does it end the concave upwards? It ends at positive infinity. It ends at positive infinity. Well, positive infinity must be always open. So from 0 to positive infinity, so this place. So it starts here, just after the 0, the concave upwards. And it ends, it keeps on, this will be concaving upwards until infinity, until x is infinity. Right. The function concaves downwards. طيب فين where does it concave downwards
then
concave downwards في هذا المكان
negative infinity
from negative infinity it
To
starts
zero.
at negative infinity until just before the zero يعني zero is what
gap.
gap so we must open it at zero so from minus infinity from here to just before the zero so that's the place where the function concaves downwards so from minus infinity
Goes
to
down.
zero the second choice okay so this is concaving upwards and the other one is concaving downwards طيب بعدين the function has a local minimum فين المينيمم look the function goes down until this point and then after this point it goes up اتذكر انه السهم لما يكون كده بعدين معنا البوينت تحت بعدين كده this means that we have a minimum and when the function decreases and then we reach to a certain place and then increases معناها انه المينيمم معنا هي 1 و 2 so the minimum is 1 and 2 he says that he wants the point so the point is 1 and 2 طيب he's then asking about the maximum the maximum
Negative one.
is when the function yes increases then we reach to a point and then decrease so this happens here increases a point and then we decrease so it's negative 1 and negative 2 and what does he want he wants the x
x وين في
في المينيمم في الماكسيمم
في الماكسيموم
so it's negative 1
negative
Negative one. Okay. طيب. The number of infinite branches. How many infinite branches do we have in this drawing?
4
We have 4 infinite branches. صح. 1 2 3 4. Highlighted with yellow. طيب. The function has a vertical asymptote. قلنا في vertical asymptote. Yes. فين ال vertical asymptote? Inside
خط
the
الأزرق
gap.
هذا
Inside the gap. فين؟ لا مش الأزرق. الأزرق هو السلانت asymptote. Vertical.
vertical الأسود
الفيرتيكال هنا هذا الفيرتيكال دائما يكون الايكويشن تبعه x is equal to a
x equal to a ولا
Yes.
y
وال-
الذي هذا اللي equal to l
y equals mx plus c هذا سلانت هذا مش horizontal هذاك لو هو horizontal y is equal to l but slant y equals mx plus c
شلون؟
لا هذا الازرق
أقصد
ايوه لا هذا x axis y axis they're not asymptotes ايوه الحدود حق الفانكشن مش هذا حد الفانكشن هو السلانت asymptote هو اللي بيعطف لي الفانكشن
ولا يعتبر
ايوه هذا اللي يعطف لي الفانكشن the slant asymptote so this one is x equal to 0 ليش x is equal to 0 لانه it goes through 0 so this is a vertical asymptote and what is the vertical asymptote x is equal to 0 we have a slant asymptote
yes
we see the slant asymptote the one in blue what is the equation of the slant asymptote شوف مبدئيا هذه الانسر اكيد انها خطأ
لا
because it cannot be y is equal to l غلط
سهل.
ولا x is equal to a غلط يعني I'm now in between these two answers إما y is equal to x أو y is equal to x minus 2 how do I know which one is which شوفوا كيف هذا
سوي ام x
أجي هنا I'm gonna choose a point any random point on the slant asymptote أي point واضحة بالنسبة لي مثلا هذا البوينت هذا البوينت كم وكم
1 و 2
1 و 1
وين احنا ها
is this point on the slant asymptote
يس
خلاص I'm gonna take this point and substitute it in these two equations if it works out in only one equation that equation is the correct answer يعني مثلا if you put 1 and 1 here we will have 1 equals 1 that is correct mathematically if you put it here هيكون 1 equals 1 minus 2 يعني negative 1 which is not correct mathematically so this one is not the equation and this one is the equation because the equation satisfies that point ها أنا بكتب في المكان الغلط صح؟ المفروض إنه هذا كله يكون تحت هنا so I'm choosing 1 and 1 so 1 is equal to 1 that's good here 1 is equal to negative 1 that's not good
متأكد ان ذيك البوينت 1
yes you can choose another point عادي
شنو لا
شوف الأكس كم؟
طرحت بايش من بوينت
هنا الأكس كم؟
وليش انا طلعت
1 لا that's in the curve أنا I chose a point on the slant asymptote this point هنا هذه is on the curve but أنا I'm checking now the slant asymptote so I'm gonna check a point on the slant asymptote
يعني from هنا
يعني I can-
طلعت هذه 2
أيوة بالضبط.
وانت كفلت
هذه 1 and 1 this place. I can take this point for example 0 0. I can take this point -1 and -1. These points are not on the curve, they are on the slant asymptote itself because we're checking the slant asymptote. And we're checking the equation of the slant.
عند سلام
طيب, how do I find the limit when x approaches 0 of f of x? شوف, في الجراف f of x means y. Well, y is the height of the graph. يعني كيف؟ يعني مثلا let me give you another example first to explain this. مثلا I want the limit when x approaches 1 of f of x. انت ايش تروح تسوي مثلا to find this one? You will go to x is equal to 1. فين x is equal to 1؟ في هذا المكان صح؟ You will go to x, تروح للواي. الواي هو الهايت تبع البوينت هذه. طبعا you don't stop here, لا هذا slant asymptote. انت you want the function, so you go to the function. كم الهايت تبع الفانكشن؟ 2. So this question مثلا what is the answer to it? The question I added, هذا الانسر تبعه 2. The limit when x approaches 1, the height will be 2, the value of y. مثلا another example, if I ask you what is the limit when x approaches -1 of f of x, ايش تروح تسوي؟ هتروح للجراف, هتروح لعند الاكس. x is -1. The height is not up now, the height is going down لأنه الكيرف موجود تحت. هتوصل لعند الكيرف. كم الهايت تبع الكيرف؟ It's -2. So you're gonna write here that this here is the y value. What's the y value here? -2. طيب. If I ask you what is the limit when x goes to infinity? f of x. طب نشوف. نروح ل x is equal to infinity. We'll see. x is infinity يعني somewhere here. Where do you think the function is going?
Infinity.
It goes to positive infinity. الهايت تبعها هيكون positive infinity. It's too high. We can say that the height is positive infinity. So in this case, what is the answer here? It's going to be
Infinity.
positive infinity. طيب, what about 0? The limit when x approaches 0. 0 is a gap. الآن 0 because it's a gap. We look to the left and to the right. زي ما عملنا في التيبل.
To the right.
To the left of it, what is the height of the function? It is at positive infinity. To the right of it. To the right, it's positive infinity. To the left of it, what is the height of the function? It's at negative infinity. Because these two answers are different, we say that here, that the limit does not exist. Why? Because the left is negative infinity and the right is positive infinity and they are not equal. So this is how you find the limit from the graph.
في حاجة زي الشيء. متى وقفنا هنا؟ متى واصل؟
Where do we stop? You mean here?
أيوة.
We don't stop.
ليش ما واصلناش يعني؟
we stop here because the function is here خلاص اللي هو الريد لاين. ايوه ال f of x. دحين هذا الريد لاين اللي كان مرسوم في البداية هو ال f of x. فأنا I stop at the function and I see how much.
المطلوب واي.
أيوة.
f of x يعني
you stop here. Exactly. This one, not the blue line, the red line.
لكن هنا ما في شوف ما طلب شوف x.
هي طلب f of x. لكن أنا ما فيش فأنا حواصل. هو هذا infinite branch يعني هذا هو مواصل ل infinity goes up.
طيب متى أنزل لتحت؟
If x is here, if there is nothing up. So we go down.
يعني تبع
أيوة. I go to the function. If the function is not up, so we go down. If the function is down, we go down.
إذا جات على هذا يعني infinity.
بالضبط. طيب, let's see this one. طيب, this one, he says the domain of the function. Let's see. First of all, let's read the function from the left to the right. This place, what is it? هذا infinite branch. صح? طيب, the function now is decreasing. اعتوجت عند الزيرو. Still decreasing though. لكن ايش اللي حصل؟ It was smiley, it was concaving upwards. لين رجعت concaving downwards. فالبوينت اللي between هذول التو concavities هذه احنا نسميها الآن على طول أنا عارف الآن هذه اسمها inflection point. What's an inflection point? It's the point that separates two concavities.
two concavity.
Still decreasing, decreasing. شوف, decreasing, decreasing. The point is between. Decreasing, decreasing. But it separates between happy و sad. هيكون هنا في الوسط. Between happy و sad. So that's why this is an inflection point.
Okay.
الآن this still decreasing.
Decreasing then بعدين increasing.
This place, هذا place مهم الآن ضروري أحدده على x axis. هذا 1. الآن what happened here? It's increasing. Now look at this. ال1 هذه إيش بالضبط؟ أنا هعمل highlight الآن from minus infinity until 1.
اللي decreasing.
أيوة هذا decreasing. كل هذا المكان decreasing.
من 1 إلى.
And then we're gonna highlight
infinity.
from 1 to positive infinity as what? As increasing. بالضبط. So this one is increasing. So decreasing, increasing. Okay? طيب الآن by the way there is also an inflection point here. في inflection point here بس ما حددهاش فهي مش مهمة بالنسبة لي. لأنه ليش في inflection point? Because this is sad for a small period of time and then the curve becomes happy again. So the place where it separates them is an inflection point, but because it's not specified, we don't care about it. Now let's see what does he want. He wants the domain. هل في gaps؟
لا.
يعني what's the domain? All the real numbers. ما فيش معي gaps. ما فيش except. The decrease interval. Where does the function decreases?
Decreases from negative infinity to 1.
Until 1. From minus infinity until 1. So it's this place. The increase interval. Where does it increase?
From 1 to positive infinity.
From 1 to positive infinity. Where's the inflection point? There's an inflection point which is a saddle inflection point. فين قلنا؟ At
0.
0 and 0.
Inflection point.
And the inflection point, the origin point يعني. The origin point يعني 0 0. Where is the minimum?
Minimum 1 negative 1.
Decrease point increase. So بالضبط هذه هي المينيمم اللي هي at 1 and negative 1. What does he want from me? Does he want x ولا y? Let's see. He said minimum value سكت.
Y.
And they want y. How much was y? Negative 1. Well done. طيب this last example. يلا. This place what is it?
Inflection point.
Infinite branch.
Infinite.
Then the function decreases until this point. So how much is the x value here? Negative 5. 5 here. So now after this place what happens? Increases up to here. Yes. So up to here this place is how much?
3.
Negative 3. الآن شوف negative 5 from minus infinity until negative 5 the function was decreasing. صح? And then from negative 5 to negative 3 the function is increasing. The graph is increasing. Then it's decreasing again from negative 3
to
all the way down to negative 1. So this one is decreasing.
From negative 1 to positive infinity.
And from minus 1 to positive infinity, the function is increasing again. So here we're increasing again. Again, we always look at the function from the left to the right. And this place here is an infinite branch. So, what is the maximum point? Maximum يعني أدور إيش؟ أدور going up, then the point, and then going down. Where does this happen?
في النيجاتيف 3.
في النيجاتيف 3 و 4.
هذه 4.
Yes. So the maximum point is negative 3 4. خلينا نرجع بعد شوية. The number of infinite branches. كم number of infinite branches in this graph? 2 infinite branches. The number of asymptotes. هذا الجراف ما فيش فيه asymptotes. لأنه مش مقطع. زي ما هذاك الجراف كان مقطع قطعتين.
مقطع فيها asymptotes.
أيوة فيها asymptotes. So this one has 0 infinite asymptotes اللي هم البوردر لاينز الحدود اللي يعطوا في الفانكشن. The limit when x approaches minus 1. نروح لعند العكس. Minus 1. We see how much is y. How much is y? 0. So the limit is equal to 0. The last question. The function is not differentiable or not defined, the derivative is not defined when a is how much? Look, not differentiable. The function will always be not differentiable at sharp edges. كيف يعني at sharp edges? We have two sharp edges in this drawing.
Yeah.
This one is a sharp edge. This one is a sharp edge. It's not a smooth curve. It's a sharp edge. لما تكون الفانكشن معها sharp edges معناها بتكون الفانكشن not differentiable there. يعني we cannot draw a tangent here. So where is it not differentiable? At two places. What are these two places?
Negative
-5 or -1.
بس.
بس.
يا سلام. ايش